Now let's do a more deep dive in CAP theorem. Scenarios where you pick either consistency or availability because partition tolerance is a given in distributed system. So the request comes update balance equal to 1000 for this account. So the write request goes to master one. Okay, so the earlier balance was 500. So this person has updated it to 1000 now in master one. But there is a network partition between master one and master two. So master two's account balance still remains at 500. Now comes the interesting part. That when a read request comes to fetch balance for, so read request comes to this person, this database, read for ACC01. Now there are two possible scenarios. One is that this database gives the stale balance of 500. So this is the first scenario. This person replies 500. So that means we are not sending an error response and we are sending a stale data. In chat box, can you reply what is this scenario? What we have chosen here? Exactly. Exactly. Thank you. So this is the AP, right? And the second option is that this person receives a 503 service unavailable error here. So we did not send the stale data. Our system is still consistent, but not available. This is CP. Now let's see a simpler scenario where we have a single master. Okay. Okay. First, let's understand the properties of this setup so that we can do a deep dive in this. All writes are done on master, right? No write should be going to any replica. Replicas keep themselves updated so that in the event of the master going down, one of the replicas can become the new master. So if this is the master, these are the replicas, let's say R1, R2, R3. So they are keeping updated themselves from the master. The writes are going to master only. Okay, writes are not allowed to go on replicas. Then reads can go to master or they can go to replicas. And at the master level, if we talk about the writes part, right? So since there is only one server where writes are going, that means there is no question of partition tolerance here. Oh, sorry, no question of a partition here. Right? Partition cannot happen. Okay, so let's see the scenario one, that read write are served from the master itself. And so we saw that this is master, the, these are the replicas. Right? Now let's say that all reads and all writes are going only to the master. Right? So that means this system is always consistent. Yeah, Aparna Mahima, your questions, we can take them at the end. There. Let's first understand what is Kep theorem and how does it work. Those are the low-level implementation details. We can talk about them later. Yeah, yeah. So in this scenario 1A, right? So we already saw that there is only one single master. So partition tolerance is always there because there is no partition. We saw that when the write requests are going to the master directly, that means it is always consistent because there is no question that a single server can respond stale data, and it is available also, this system, right? Because this master will always respond to the read requests. Now scenario 1B, writes are served from the master and reads are served from the replicas. So writes are served from the master and reads are going to the replicas. Now in this case, what can happen is that there could be a network lag. So let's say we updated the account balance to 1000 in master. Now this information has passed through the network. This information has to pass through the network and it has to go to R3. Now before it goes to R3, if someone sends a request to R3 that give me the balance, then this person can reply with 500, the stale data. So in this case, our system is not consistent. We lose the consistency. But what's the advantage here? The advantage is that our system is more scalable because I'm able to serve more read requests, and it is a low latency system. Why it is a low latency system? Because in case where lot of read requests, thousands of read requests are coming concurrently in our system, instead of only one server responding to all those thousands of requests, we have an army of servers to respond to those requests. So definitely we will be able to serve them with low latency. Now let's throw some more complexity in that single master system. So the writes are as usual, they are coming to the master. And okay, I have a question. Slide scenario 1A. Since all three properties CAP are intact, it could mean that it's not a distributed system, is it? Yes, because the write requests are going to only one server, right? So that means it is not a distributed system. What distributed system means, the same means that my writes are happening at several locations, at several servers. So if I go back to this slide, this is a classic uh, RDBMS setup. This this one is a classic RDBMS setup, right? Where only one server is responding to all the write requests. Okay. So moving to this single master system, yeah. So where we have network partition between primary and replicas. Right? So the old balance is, yeah. So now there is a network partition between the primary and replica. That means replicas will not be in sync with master anymore. Yeah. So now in this case, what can happen is that replicas replicas will think that the master is not in the system, right? Because the network partition has been the partition is there. There is a question. So Manish, coming to your question, so this is true for a distributed system, right? In a distributed system, whenever there is a network partition, we can choose only consistency or availability. When we look at this example, where there is only a single master, right, and the writes are going to only a single master, this is not a distributed system in true sense. So if we talk about the distributed system, so I'll give you an example if I've confused you. Let me give you two examples. Okay. One is, let's say let's say there is a bank setup. Okay. And in a bank, people are sending request that they want to update their balances. Okay, so lot of requests are coming for account one, account two, account 1000. Right? So there are many concurrent requests coming to the system. Now let's imagine that we have application servers here. We have lot of application servers here, which are which are serving to these customer requests for updating balance. And imagine there is no database here. Okay, there is no database here. Just imagine that they are updating balance in their in those servers itself. Just for simplicity. Okay. Now, if all of these servers can accept the right request, let's say these two servers are in North America, this is in EU, this is in Asia. So if all of these servers can accept the right request, then this is a distributed system. And the second example in now, and the second example would be, let's say I say that okay, all the requests should come to only this one server. So in that case is okay, maybe I'll be able to serve 1000 concurrent requests. Maybe I'll be able to serve 10,000 concurrent requests. There will come a time when this server will not be enough. When this server is not enough, what options do I have? Option one is that I do vertical scaling. Right? That means I make this box more beefier. I add more CPUs, I add more RAMs, right? So this becomes a bigger box now. This is vertical scaling. And of course, vertical scaling has a limit, right? I cannot keep on making this server infinitely huge that it will be able to serve a load of Facebook or Google. That means I will have, that means vertical scaling won't be an option and I will have to go to horizontal scaling. And by horizontal scaling, we mean that this one big server has to be broken down into lot of small commodity servers. And then all of these servers, if this is a load balancer, all of these servers are capable of serving the write request. This becomes a distributed system. And whenever there is a network partition, we will have two partitions of servers, right? And if the write request comes to partition one, if this is partition one, this is partition two, write request comes to this partition one, that data will not be reflected into the servers of partition two because of this network partition, right? And then the same question will arise that the read request, when they come to partition two, either we serve the stale data, which makes the system available, or we send an error that, hey, I do not have the most updated data, I give you error. And then that systems become CP, and in this case, systems become EP. I hope it is clear now. Maybe in chat box, you can comment. Okay. Yeah, thank you for that question, Manish. Maybe in my next class, I will approach these slides first with this one so that everybody will have a better understanding. Okay, let's move to the next. Aparna, in that case, there will be one common database or different DB servers with replications. It depends. If you again, it depends that the same concept applies here. Let's say this one here, right? Let's say this is a DB server, and there are a lot of applications. Let me create a fresh page. Let's say these are my application servers. Application servers. This is a load balancer. So I have hundreds of application servers. Oh, let me change the ink color. Okay. And this is the DB. Let's say there is only one DB. Now all the requests are coming to this one DB server. Okay, fine. Maybe this person, this database is able to serve 10,000 of requests per second. Fine. Black Friday comes, it shoots up to 100,000 requests per second. This is going to crash. Now, what option do I have? Again, same thing. I can do vertical scaling or I can do horizontal scaling. And please use question and answer box only for the questions. Right? For the comments like I agree or yes, thanks, please use the chat box. I'm looking at the chat box, but for questions, I'm looking only at the question and answer box. Thank you. Mahima is asking, can a DS have vertical partitioning? I'm not sure what is vertical partitioning in this case. Maybe we can look at it in the end because we still have so many slides to cover and already 50 minutes have gone. Okay. Okay, so we have covered scenario 1A, 1B. Okay, yes, we were talking about this scenario 2. Just give me a moment. I'll just clear the questions because it's confusing me. Can you please elaborate on network partition? Sai, I have already covered it and I can go it on again, but it will take a lot of time because my understanding is that this is an advanced level class, right? So these cap theorem has been covered in great detail by Omkar already in one of the fundamental session. Yes, but okay, I'll say it again in a brief summary. So let me use the previous. This is 30. Okay, I'll use this one. Let's say this is database one, this is database two, this is database three, and this is a load balancer. It could be a load balancer or it could be a router. Any logic which is just making sure that the requests are going evenly to any one of the three databases. Okay. Now let's say there is one account ACC1. Its balance is 1000. We were using 500 earlier. 500, same 500 here, same 500 here. Okay. Now write request can go to any of the server, DB1, DB2, or DB3. Okay. Let's say first request comes. It says update balance to 1000. So here it is updated to 1000, and at the same time that data is passed to DB1 and DB3 also. That please update balance to 1000 for this ACC1. So they will also update to 1000 immediately. Okay, all good. Now another request comes. This was request one. Now request comes update balance to 2000 for the same ACC1. Okay. Let's say this time the request comes to this person, this database, DB3. Now, meanwhile, an angry shark has attacked the fiber optics here and it has broken down the network here. So that means we have two partitions now. Let's say this is partition one, this is partition two, right? Now, when request has come that update to 2000, this person has successfully changed it to 2000, but this person cannot relay that information to DB1 and DB2 now, right? So these guys, they still have account balance as 1000, right? So this is network partition. Yeah. Yeah. Partition partition happens whenever there is a network failure. Whenever there is a network failure, partition will happen. So whenever partition comes to your mind, just imagine one great white shark is eating some fiber optics somewhere and database one and database two cannot talk to each other anymore, or server one and server two cannot talk to each other anymore. Let me resolve this question. Yeah, Kamal, your question is interesting. Under what kind of circumstances vertical scaling is the only option? Yeah, we will talk about it. It's a good question. Yeah, I think let's take a moment now. So because the basic fundamentals of cap theorem we have discussed, let's go through the questions again. So Mahima, when do we talk about cap theorem in the system design interview at the end when discussing the storage tier? Yeah. So you can talk about it. Yes, when you are talking about discussing the storage tier. Yes, definitely. So because when you are discussing the storage tier at the same time, you also have to make a decision what kind of database you will be using. So discussion will start from the requirements. Right? So you already have noticed the requirements. Let's say you were designing a bank system or you were designing some kind of ticket management system. So in those cases, the requirements tell you that your system should be consistent. You cannot send stale data to person who is trying to book a ticket for a movie. So in that case, you can talk about that. Okay, I know that this is going to be a distributed system and partition tolerance has to be there. And since the requirement says that I cannot have stale data when somebody is booking a ticket, so this seems to be a CP system to me. And in that case, these are my choices for the database. If this is you are designing Twitter, right? In that case, some celebrity, let's say The Rock, has tweeted about latest movie Red Notice. Right? Now, it's okay as a follower, I get to see that tweet from Rock after some lag. So in that case, I'm okay with making my system available but not consistent. Right? So you can talk about it with your interviewer. Good question. Let's move to the next question. What determines if the read request is coming to which master? Yeah, so in these cases, you have a coordinator, or you can have even load balancers, you can have proxy systems. Right? So I will encourage you to read about the Cassandra. So whenever you want to have a more solid understanding of distributed databases, read about Cassandra. It has a great architecture. You will learn a lot, and you can use those fundamentals in your interviews. Actually, I'm planning to do a class on that also in future. Yeah, let me know in the comment boxes if you would like to have such kind of class. In terms of CP, in order to throw error, will the data be compared against all the replicas in order to determine the? Yeah, again, Mahima, this is more in the details of how we are going to design the distributed database. Again, it's out of the scope of this class, but definitely a interesting topic to be discussed. How will we know if the server is out of sync and 503 has to be sent? Again, Aparna, it's on similar to this. previous question. Okay. Ranji's question we have answered. Manish question answered. Aparna's question has been answered. Mahima, can a DS have vertical partitioning? Can a distributed system have vertical partitioning? Mahima, can you please unmute yourself and explain what do you mean by vertical partitioning? Okay, allowed to talk. Yeah, you can speak now, Mahima.
Yeah, thanks for the class, Raja. So, in the previous slides, when you were discussing about how in a big system like Facebook or Twitter, we cannot have like vertical partitioning, we would go with the horizontal one. So, I was trying to understand like why would you choose that, and like can like which scenarios can we have like vertical partitioning in a distributed system?
You are saying vertical scaling, right? Not vertical partition.
Right. Yeah. 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 Yeah, that's what I
Yeah.
meant.
Okay. Okay. Yeah. Yeah. Your question is similar to Kamal's question. Yeah. Okay. Thank you. Yeah. So Kamal also has similar question. Under what circumstances vertical scaling is the only option? Yeah. So I would say in cases of the practical implementations, you will have vertical scaling. Like for example, in my team, we were working on some service, and we had this Postgres database server, and that server had 8 cores. It was a small service, so it had 8 cores, and the system was working fine for some time. Then during the sale time, it happened that the request started increasing from 1,000 requests per second to 10,000 requests per second. So what we did was that by some load testing, we came to know that, okay, if we increase it to 32 cores, that means if I make it 4 times of the current database, then I can easily handle these 10,000 requests per second. And since the sale was very near, we did that. We did the vertical partitioning immediately, and we were able to serve the 10,000 requests per second. And another twist in the story was that it was a it was a it was a system which required transactions, right? So RDBMS was the only option for us. Right? Now the problem came when soon from 10,000 requests per second we started hitting 50,000 requests per second. So again, we had to bite the bullet for some time. So what we did was that this time we again increased it from 32 cores. I don't remember exactly, but it was some beefy box, let's say 128 cores. So we increased it to 128 cores. This was the action one, but action two was that we also started looking into other distributed SQL options. So we have some distributed SQL options like Google's Spanner, and we have Cockroach DB, so and Yogabyte DB. So we started doing POC on these three databases, and by the time this 128 core would have been a bottleneck, we changed our system. We broke it down into further microservices, and we moved to this architecture. So yeah, so this is the answer, Kamal and Mahima, that yes, vertical partitioning is an option, and it is a very practical option. In fact, you should not blindly go for horizontal scaling. If you look at all the companies which were built, today's big companies, when they were built, for many years they just did vertical scaling, because horizontal scaling means you go into the complexities of distributed system, distributed transactions, and there are a lot of failure scenarios possible. I hope that's clear. Thank you for the good question. Can we have master and replicas based on the region? Yes, we can definitely have. Again, if you read about the Cassandra's architecture, you will get good understanding about it. And we do. Yes, definitely you should talk about it in the interview. But don't only talk because you have to talk. Uh, avoid, I don't know what happened. Suddenly all the questions are gone from the question and answer box. Okay, sorry. There was one question I think was still there and it has gone. Yeah, we will touch on it, Sai. Yes, Kamal. So actually not true actually. What is monolith? Right. So monolith is that when you have a one big service which is doing a lot of work, and when you break it down into logical separate pieces as individual services, it becomes microservices. So if you are asked to question of if we are asked the question of vertical scaling use case. Okay, yeah. So if somebody asks you in the interview that, okay, in what circumstances you will go for vertical scaling, right? So you can, yes, you can I think, yeah, you are on the right direction. So you can talk about the example which I gave you. You can tell that looking at the future requirements, right? If let's say you know that if I do the vertical scaling, if I just double the capacity of my current server and I know that I'm good for next 2 to 3 years, then as a leader in my team, I will take that decision first, that I will just do the vertical scaling. And in the parallel, we will also prioritize that we change and modify our system in such a way, we refactor our system in such a way that we are ready for the distributed system as well. Kamal, your hand is raised. Do you still have any question? Okay, thank you. Okay, I think we have talked a lot. Let's uh, take 5 minutes break. It will be good to rest our minds for some time. Maharajan for Cassandra, uh, I think there is a paper also, and for Cassandra, there are a lot of good courses also. Like what I did was there was a course on Udemy for Cassandra. I saw that course. I'll maybe find a good resource and share it with the ops team. They can share it with you. Yes, recordings will be shared, Bhavika, sorry. Yes, we will talk about the row-oriented and columnar a bit, which was a course in Udemy. Yes, I'll look into it and I'll share it. Yeah, we will go into row-oriented and column-oriented. Okay, let's move ahead. Okay, Let's see some famous databases with default settings and where they fall in CAP theorem. So when we talk about RDBMS with a single master system or single master system with reads allowed from replicas. So this is similar to what we have discussed previously, right, in these slides. So this is the same scenario. And when we talk about the fault tolerance, so we can have automatic failovers. Right? So in what happens is that there is always a replica, say secondary server, which is in sync with the primary. And when primary goes down, there is a system which detects, okay, that failure has occurred and secondary can be promoted to become the primary server. So this is the fault tolerance mechanism in that setup. I'll skip this slide for now.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today